This is our fourth session of Arithmetic Progression NCERT Mathematics Exercise 1.1. In our last session we have completed up to your exercise 4th main, up to your 6 problems we have completed. So now in this session we are going to start from 7th problem onwards. So what's your 7th problem? Have a look here children. 0, minus 4, minus 8, minus 12, so on. Which type of a sequence it is? It is an infinite sequence. What's your main question here? Check whether it is an arithmetic progression. If it is an AP, find D and the next 3 terms. One problem already done here. Have a look. So start writing the terms A1, A2, A3, A4. So first term A1 is equal to A is equal to 0. Common difference A2 minus A1 minus 4 minus 0. Minus 4 minus 0 will be how much? Minus 4. Then another common difference A3 minus A2 minus 8 minus of minus 4. Minus into minus will be plus. Minus 8 plus 4 will be minus 4. Look here, this D and this D is constant, having a fixed number. Therefore, the sequence is in arithmetic progression. Yes, it is in AP. If it is in AP, find D is your question. Already we found that common difference D is equal to minus 4. What's the first term? A is equal to 0. Find the next 3 terms. 4 terms are here children. So what will be the next term? 5th term A5. A5 is equal to A plus 4D. That is 0 plus 4 into minus 4. Plus into minus. Minus 4 4s are 16. 0 minus 16 will be minus 16. A6. What's the general form of A6? A plus 5D. A value is 0. D value is minus 4. 0 plus 5 into minus 4. Plus into minus. Minus 5 4s are 20. 0 minus 20 will be minus 20. What's your last term here? A7. A7 general form is A plus 60. A value is 0. D value minus 4. 6 into minus 4 will be minus 24. That is equal to minus 24. Therefore, the next 3 terms are minus 60, minus 20 and minus 24. Okay. Let's do the next one, 8th one. What's your 8th sub question? See here, what is this? All are looking same. Definitely you say that no, it's not an AP. No, you have to just check first, then we have to confirm here. So one more condition you have to remember, common difference may be 0, may be negative, may be positive. So now let's start numbering A1, A2, A3, A4. See here, 4 are same now. So what might be next 3 terms? Next 3 also same if they are in AP. Let's check whether they are in AP or not. A1 is equal to, first term is equal to minus 1 by 2. Your common difference A2 minus A1. What's your A2? Minus 1 by 2. Minus of minus 1 by 2. Bracket you have to use. Minus into minus. Plus 1 by 2. What happens here children? Cancel. 0. Then here, next common difference, A3 minus A2. A3 value is minus 1 by 2, minus of minus 1 by 2. That will be minus into minus plus 1 by 2. Again, 0. Yes, D is constant with a fixed value. D is having 0, 0. Therefore, what you can say? Yes, the given sequence is in AP. Yes, it is in AP. If it is in AP, common difference value is 0 and your A value is minus 1 by 2. So when you have a common difference 0, then all terms will be equal. What are the next 3 terms here? A5. General form of A5, A plus 4D. Minus 1 by 2 plus 4 into 0. Minus 1 by 2. 4 into 0 is not 4. Most of the people will do an exam. 4 into 0, they'll write value minus 1 by 2 plus 5 into 0. Minus 1 by 2 plus 0 minus 1 by 2. A7 general form A plus 60 minus 1 by 2 plus 6 into 0 minus 1 by 2 plus 0 is equal to minus 1 by 2. Therefore, the next three terms are minus 1 by 2, minus 1 by 2 and minus 1 by 2. Okay. So, what's your ninth problem here? Ninth problem. 1, 3, 9, 27. See here, it's looking like multiple of 3. Every sequence will be having a rule, right? So here 0 is added for next term. There minus 4 is added for every term. But here look here, 3 minus 1 is 2. 9 minus 3 will be 6. So directly you can say it is not in AP. 1 3s are 3, 3 3s are 9, 9 3s are 27. Look here, this progression you don't know, it is a multiple of a 3. Multiple of a 3 we call it as a common ratio. This type of a progression is called as a geometric progression. Before years we used to have GP also, but this year not there. So what's our question here? Check whether this is in AP or not. Directly you can say it is not in AP, but we have to follow the rules. First term A1, A2, A3, A4, so on. So here A1 is equal to A is equal to 1. D is equal to A2 minus A1. That will be 3 minus 1 will be 2. Okay, 3 minus 1 is how much? 2. Same manner, next D. Also next D, A3 minus A2. 9 minus 3 will be 6. Therefore, the D is not constant. D is not having a fixed value. Therefore, no, the given sequence, it is not in arithmetic progression. So, quickly let's move on to the 10th problem. A, 2A, 3A, 4A, so on. Oh, what is this multiple of A here? So again, multiple or sum we have to check out, no problem. We can do addition. A plus A, 2A, 2A plus A, 3A, 3A plus A, 4A. What is the rule? Rule, every term to obtain A is added. So directly by seeing some type of sequence, we can say whether it is in AP or not. A1, A2, A3, A4, so on. Okay. So now, also your first term A1 is equal to A is equal to A. Common difference, A2 minus A1 is equal to 2A minus A. Look here children, when you have like this, 2A minus A, directly you can say A. How could you get this one? In these two, A is common, right? Take your A here, write down remaining. Number 2 minus 1 is equal to 1A. 1A can be written as only A. Next difference here, A3 minus A2. A3 value is 3A. 3A minus 2A will be same manner. If you want, you can take out A common. 3 minus 2 will be 1A. So what you can say here, therefore the sequence is in AP. If it is in AP, what you need to find? You need to find D and the next three terms. So look here, therefore the D is constant. Yes, the given sequence is in AP. Is in AP. Okay, if it is in AP, what's the next term? Semi-children, what will be the next term? 5A, 6A, 7A. So let's find out here. A5, A plus 4D. What's your A value here? A plus 4 into A. That will be A plus 4A. 4A plus A will be 5A. Directly you can do, or you can take common and you can add. If you don't know children, you are at the starting stage, just you can take out common, slowly you do. Suppose if you are perfect, directly you can add. 5a. D value is a, no? A plus 5a is equal to 6a. A7. A plus 6d is equal to a plus 6 into a. That is equal to a plus 6a is equal to 7a. Therefore, 5a, 6a and 7a. What are the next three terms? 5a, 6a and 7a. Okay, let's start the 11th sub-question here. What is the 11th sub-question, children? A square, a cube, a power 4. Look here how it is. So on also there. A. If you add a, it must be 2a. But here what's going on? A is multiplied here. What is a into a? A square. A square into a cube. A cube into a power 4. Okay, let's start numbering. So directly you can say it is not in AP, it is in GP. But we have to prove it, right? A1, A2, A3, A4. Let's start first term. A1 is equal to A is equal to A. D is equal to A2 minus A1 is equal to A square minus A. How could you write this? Take out A common. A minus 1. Another D. What's here? Another D. A3 minus A2. A cube minus A square. Look here children. Here 2 A's are common. So how could you write this? A square into A minus 1. So D is not having a fixed value. Therefore, no, the given, it is not a sequence. This sequence is not in AP. It is not in arithmetic progression. Yes, we can end up there itself. Coming to your 12th problem here. On your 12th, root 2, root 8, root 18, root 32, so on. So look here. Oh, 2, 8, 18, 32. I think this is not in AP. No, we cannot judge by seeing this. But how can we do this? We have to simplify the SERT. How do you simplify? You know already. So let's start here. Root 2. Root 8 can be rewritten as multiple of a perfect square. So root 8 can be written as 4 2s are 8. So look here. Where shall I write? So let's see here. Root 8, how can you write? Root 4 into root 2. Root 4 is a perfect square. So you write it as 2 root 2. Same manner, root 18. Root 18, how could you write, children? Root 18. 18 is a multiple of which perfect square? You guess it. So it might be 9 2s. Root 9 value is 3 root 2. Then again, what's your next one? 32. 16 into root 2. That you can write it as 4 root 2. So this is the way of simplifying a SERT. Now write it here. 2 root 2, 3 root 2, 4 root 2, so on. Start numbering your terms. A1, A2, A3, A4. Hold on children, look here. A, 1 root 2, 2 root 2, 3 root 2, 4 root 2. Yes, it might be in AP, no? What will be the next 3 terms? 5 root 2, 6 root 2, 7 root 2. Directly you can say, but we have to do it. A1 is equal to A is equal to root 2. D is equal to A2 minus A1. That is equal to 2 root 2 minus root 2. Okay, children, in these two, what is common? Root 2 is common. That is 2 minus 1 will be root 2. Okay, 2 minus 1 is 1 now. 1 no need of writing. 1 into root 2 will be root 2. Then A3 minus A2. What is your A3 value? 3 root 2 minus 2 root 2. So take out root 2 common here. 3 minus 2 will be root 2. Okay. So what you can say, therefore D is having a fixed value. Therefore the given sequence, yes, it is in arithmetic progression. Completed? No, if it is in AP, find the next three terms. What's your D? D is root 2 and A is also root 2. So coming to your next term, what will be the next term? A5. What is A5? General form. A plus 4D. A value is root 2 and D value is root 2. Substitute here. Root 2 plus 4 root 2. Look here children, in these two, root 2 is common. So search common means you have to take this side. 1 plus 4. That will be 5 root 2. Follow? Next. What's your A6? A plus 5D. Root 2 plus 5 into root 2. That will be root 2 plus 5 root 2. Again take out root 2 common. 1 plus 5 is equal to 6 root 2. Also the last term here, A7 is equal to A plus 6D. A value is root 2 plus 6 into root 2 is equal to root 2 plus 6 root 2. Take out root 2 common. What you are going to get? 1 plus 6. That means 7 root 2. Therefore, what are the next three terms children? 5 root 2, 6 root 2 and 7 root 2 are the next three terms of the given sequence. So, finally, we have three more problems, right? Yes. Let's have a look at this. Next one will be 13th problem. Root 3, root 6, root 9, root 12, so on. So here, root 3, okay, root 6, okay, we cannot simplify. Root 9, 3, root 12, you can write it as 2 root 3. See here, all are different, means it cannot be in AP. Let's check it out. A1, A2, A3, A4. A1 is equal to root 3, that is equal to A. D is equal to A2 minus A1. Root 6 minus root 3. I cannot simplify further, so as it is. Another D, A3 minus A2. What's A3? Root 9 minus root 6. Can write it as 3 minus root 6. Directly these two are not constant. Therefore, no, the given sequence is not in arithmetic progression. End up here itself. No need of continuing further. 14th problem. Last but one. 1 square, 3 square, 5 square, 7 square, so on. Oh, what is this? How could we find this? Let's apply the squares table. 1 ones are 1, 3 threes are 9, 5 fives are 25, 7 sevens are 49. Okay children, you are comfortable now? Let's start. A1, A2, A3, A4. A1 is equal to A is equal to 1. Common difference, A2 minus A1. 9 minus 1 will be 8. And another common difference, A3 minus A2. That will be 25 minus 9. Oh, look here. This is what? 16. Okay. 8 and 16 same, constant? No, no. Therefore, no, the sequence is not in arithmetic progression. End up here itself, not further. So last and final problem in this exercise. What is the last problem here? 1 square, 5 square, 7 square, comma 73. Okay. So again, just simplify this one. 1 ones are 1, 5 fives are 25, 7 sevens are 49, 73, so on. Now we are comfortable now children. So write this A1, A2, A3, A4. Okay. First term A1 is equal to A is equal to 1. And D, A2 minus A1. What's A2? 25 minus 1 will be 24. Let's find out next D here. A3 minus A2. That will be 49 minus 25. Look here, your D value is constant, fixed value. Therefore, yes, it is in arithmetic progression. If it is in AP, what's your D value here? 24. And what is your A value? 1. Find the next three terms. Next three terms will be fifth term. General form is A5 general form is A plus 4D. 1 plus 4 into 24. That will be 4 24s are how much? 96. 1 plus 96 will be 97. And your sixth term A plus 5D. 1 plus 5 into 24. How much is this, children? 5 24s are 5 4s are 20, 5 is a 10, 120. That will be 121. Last term A7 is equal to A plus 60. 1 plus 6 into 24. 1 plus 144. Sum will be 145. Therefore, the next three terms are 97, 121 and 145. With this, we are going to end our exercise 1.1, children. Thank you for watching. Please subscribe.